Okay. X to the minus 2 plus 3x to the minus 1 plus 2 equals 0. So let's start with just making sure we're okay with how to rewrite those. X to the negative 2 is the same thing as 1 over x squared. And 3x to the negative 1 would be the same thing as 3 over x. The exponent's on the x term there only, not on the whole thing. So the 3 doesn't move with it, right? It's the reciprocal of x, then times 3, or 3 over x, or 3 times 1 over x if you want. Okay, so that's the same thing as this. Now what? Okay. So what would the least common denominator be for those three things? X squared, right? Build up to the higher one. So x squared. LCD is x squared. X couldn't possibly be 0. Then what? Yeah. Make them x squared or use that least common denominator to, get rid of everything, right? So I'm going to multiply everybody by x squared. And then what happens is a bunch of stuff cancels. 1 plus 3x plus 2x squared equals 0. And then we're solving a quadratic. So I'm just going to rearrange to have the leading term in front. That might factor or just, jump to quadratic formula. I don't think it's going to, well, yeah, I guess it does factor. I'd probably go to the quadratic formula though, pretty much as soon as I see that leading coefficient that's not 1, but you can factor it or do I think anyway, or do quadratic formula. Either way is fine. Negative b squared minus 4ac over 2a. So that's 9 minus 8. So negative 1/2 and negative 1. Neither of which is 0 or would make any of the original terms undefined, right? So those are both fine. So this has two solutions. There they are. Yep.
So for the vaccine, I got was 2 times 1 is 2. What times is 2 to make to 3 is 1 and 2.
Right. So when you do that, then because of the leading coefficient, just be careful how you factor it. Right? Like you find those, but then it's not quite as direct as when the leading coefficient's 1. So the way you use those would be to write that middle term sort of broken up. And then you factor by grouping. And so you get 2x plus 1 times x plus 1, which is going to get you to those. Right, yeah, no. So you do the AC thing and figure out, what multiplies to that and what adds to 3, which would be 2 and 1, that's correct. But then like the way you use those is a little different to actually write down the factor. Yeah. Okay. Is that okay with that? Yeah, okay, right on. If you want, you can also, from the beginning, if you like recognize that sort of like quadratic, form, shape, whatever, you can factor it with the factors being like 1/x and 1/x, and you can do it that way instead. But if you don't see that, then this is a little more direct, I guess. Okay. Anything else we know we want to talk about right now? Go ahead. Oh, okay. Sorry. Sure. Okay, so let's say we want to find the domain of that. What do we need to do? Domain, we're always talking about X values because that's what domain means, right? X values where it's defined. What would make this or cause this to be undefined? Where would it not work? What could go wrong? If the stuff underneath this square root is a negative, right? So does the -1 have anything to do with anything? Now think about it graphically, that's just a shift down, right? That's not going to affect domain. So I don't care about that, right? That's just, noise. What I care about is making sure that the circle thing, the stuff inside the square root cannot be negative, because if it is, and I take its square root, I don't get a real number back. That means it's undefined. So what we need to do then is figure out where this is not negative. So I want it to be greater than or equal to 0. No problem. Basically solving that inequality. You can, do it direct. It's a linear thing. You can do that directly if you want. You could solve the equation and then like test whatever version of that works best for you. If I subtract 3 here and then divide by 2, I get that X has to be bigger than or equal to -3/2. Or another way to look at that, you could solve the equation and then do the testing thing on either side, whatever you're more comfortable with or whatever makes more sense to you. -3 over here, 0 over here. This would be fine, this would not. So I get to the same thing. What's the domain? -3/2 to infinity. -3/2 would be the leftmost endpoint, like the starting point for this function, because X needs to be bigger than or equal to 3/2 in order for this to be defined. This weird little squiggly thing is a 3. Okay. Okay. Yeah. How's that different for a cube root? Again? Yeah. For a cube root, so the reason that a square root does what it does is because it's a square root, and that's how square roots work. Cube roots work differently, right? Cube roots, you can take the cube root of a positive number and you get a positive number. You can take the cube root of a negative number, you just get a negative number, right? Negatives cancel in pairs. And now we're talking about 3 because it's a cube root. So we don't have the same problem or the same restrictions here. So kind of there's nothing to really worry about here as long as the stuff inside is, nice enough. 3 plus 2x is about as nice as anything can get. So this is defined everywhere. And again, that's because it's a cube root. Okay. I think Josephine has something else. On the practice thing. Okay. I'm just gonna make up something, related, similar. So going back and forth between radicals and rational exponents. How else can we write the cube root of x squared? X to the 2/3. Denominator gives you the index of the radical. Numerator is the, like power, right? So those things are the same. So how could I rewrite the quantity x plus 5 to the negative 3/4 as an expression where I use roots and radicals and stuff instead? That flips it, right? So the negative is the reciprocal, so it's 1 over. Fourth root of x plus 5 to the 3rd. So I'm just making it up.
Oh, yeah, I was like,
Root, power. I highlighted those things in the opposite way than the previous one, which is a really good way to do things, probably. You doofus. There we go. And then the negative is the reciprocal part. Okay.
so that's
How to get what?
the bottom, the x squared plus 5.
This is what we started with.
Oh,
So I gave you this and I said, hey, write this thing using
I was
radicals
reading from
instead.
Left to right, not left to right.
Right, yeah, no. We just need to be able to go either direction, right? There are a couple of practice tests and the review and stuff where, it's, here's a thing with a radical, write it as a rational exponent instead, or vice versa. So,
Okay.
yeah, just being able to go back and forth between those two things. And I mean, that's all I'm looking for you to do there is just rewrite the other way. Okay? There's nothing to like solve or work out or do. It's just rewriting it using the other, notation. Okay. 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 Well, I prepared some problems that I want you to do. And here they are. And in 20 minutes or so, we will reconvene and talk through some of these. I want you to work in groups. I'm going to call on people to, help us through these. So we all want to make sure that we're